Hi everyone, welcome to Vedantu J English. I'm Diksha Kaushal, your chemistry master teacher. Everybody, let me know in the comment section if I'm clearly visible and audible to you. Yes, students, let me know in the chat box if I'm clearly visible and audible to all of you or not. Okay, so this class is generic class for the students. If you're in 11th class, if you're in 12th class, if you're a dropper, right? Preparing for any exam where you have chemistry, right? Be it board exam, you have JEE Mains, you have NEET, you have Comet, any exam that you're preparing for, this is going to be a useful session for you, right? So here, what we are going to talk about, firstly, there are some topics, right, which are very useful. I'm not going to teach you the entire chapter, right? Let me be very, very clear on that. What I'm going to teach you here is like electronic configurations, right? Like off-bow principle, Pauli's principle, important things that are useful in electronic configuration, important things that are useful from periodic table that are useful in your DNF block in class 12, right? And important things from chemical bonding that are directly related to coordination chemistry that will be helpful in coordination chemistry, as well as if your base of inorganic is not good. See, inorganic, wait a minute, let me know if I am visible. I hope so, I'm not stuck. Okay, yes. For example, let's talk about organic chemistry, right? So in organic chemistry as well, you really need to have a good base of inorganic, because chemical bonding, how molecules are formed, and electronic configuration, directly it is very useful in your organic chemistry. You won't be able to understand the core of organic chemistry if inorganic chemistry is weak, right? Because there are so many factors that are in inorganic chemistry which are useful directly in organic chemistry to help you with the GOC, the basics, right? So that's why this session, and it's not going to be a long session, it's going to be a very, very short session, like maybe 45 minutes or 1 hour, right? We're going to talk about all the things, okay? Yes, everybody, a bit sad due to the, yes, so many things actually. If those students who don't know, I am in that area, I live in that area where I can't, like, those students who know, right? So I live very near to border area. So I was in Bangalore. Yesterday I came back to Delhi because the airport nearby my house is like closely like not in the working condition. It's not operational right now, and there are so many sirens, mock drills. Uh, it's actually very, very scary sometimes. You know, when you sleep, it's just, I think. The armed forces, I really thank our armed forces, the Indian army, the way they are, you know, the way they are helping the citizens, right? The way they are saving the citizens. We are able to sleep at night only because of them. Otherwise, we are very scared that whether we will see the next morning or not. It's only because of the armed forces that we are safe, right? Whole North India is safe because of that. Otherwise, the border areas are like the situation is very tense right now. It's, I think, salute to the Indian Army, salute to the like armed forces that are there right now uh, on the border areas just to save us, right? So hats off to all the people out there. Like if in your family, if anyone in your family is in the armed forces, I salute you. I salute to the families of the people in the army. That's actually right now. Otherwise, I think it will be very. It would have been very difficult to survive such thing, right? Like missiles and all, drones. Oh my God, that is very, very scary. Night is very scary. Night is very scary. Yesterday, when I landed back, yesterday night was like we were continuously on the news channels. Even, you know, the problem is even you don't know whether the news is fake or real. That is the big problem, right? So many people, I request everyone out there, if just for views, what you are thinking is that, okay, I'll spread some wrong news, fake news, right? It creates panic, right, among citizens of India. So please don't create or like, you know, publish any fake news on YouTube just for views. Please don't do that, right? We all are together. We all are united in this. So kindly don't do that, right? the people who are living in that area knows that whenever there is such news, what impact that has in their mind, right? It is very traumatic. So please don't do that, right? If any one of those people are listening, right? Okay. Yes. Now let us talk about our chemistry. So firstly, students, I'm going to start with periodic classification. Okay. So let's start with periodic classification. Are you all ready? Yes. I don't want, guys, please, let's make this class interactive, right? Let's not talk about random stuff here, right? And please talk in English so that even I am able to, like, what if I speak in some different languages that you are not able to understand, right? So there is no use, right? If you are making this a chit chat session, right? No use of that. You have 1 year in your hand. If you are preparing for JEE 2026, you have 1 year in your hand. I know right now you will be wasting your time in the chat, and after 6 months, you will be in the panic mode, right? So, what's the advantage of that? There is no use of that. If right now you are serious, only then the probability of cracking JEE 2026 will increase. And you can see it from NEET 2025 that NTA is very serious. They are definitely going to make tough exams, right? They are definitely going to make competitive exams. And competitive exam, it's not a laddu kind of questions that will be there in the exam, right? Really good questions will be there in the exam. For that, your basics should be very strong, right? For that, you really need to concentrate on the lecture rather than here and there, right? Okay, yes. Now, let us start this. So, first thing is periodic table. So, firstly, tell me all of you, how many of you actually right now know, like you have like full periodic table, you actually have full periodic table on your tips? How many of you have full periodic table on your tips? And also let me know in the chat box, is there any lag in between the class? Is there any lag in between the class? If that is so, then let me know in the chat box. If there is, up to 3D series, ma'am. Okay. No, ma'am. Okay. No lag, ma'am. No lag. Okay, there is no lag. Actually, I even have no idea about the electricity when it, like, today at 7 p.m. there will be full blackout here. So I have no idea, right? So that's why I'm asking again, because in my screen, the screen is lagging, right? So that's why I'm asking you that, right? Okay. In my screen, it is lagging, but I don't know if there it is lagging or not. Internet also, you know, the situation. That's why internet is not so very good, right? Now, no lag, ma'am. Okay, okay. Guys, please, thoda bahut you please adjust, because it's not in my hand. I have to have 5G internet, but what to do, right? Because of the security, the internet is not very fast here, right? The internet is not very fast because of the security reasons. Okay? Yes. Now, if you see this here, this is full periodic table that should be on your tips, ma'am. What are the things that should be on our tips? So, first thing that is in your tips is first group, second group, then you have 13th group, 14th, 15th, 16th, 17th, and then 18th. These groups should be on your tips. Then you have 3D series that should be on your tips, right? These are the things, right, that you should definitely know. But ma'am, it's not easy to cram it all, right? Okay, some things you might know, some things you might not know. So to cram all of this together, we need mnemonics, okay? And mnemonics, you can either, see, I'll give you the mnemonics in English, right? I'll also give you the mnemonics in Hindi and English. I'll give you the mnemonics, right? But if you want to convert this into your regional language, then you can convert it into your regional language, okay? That's totally your choice. But if you talk about the mnemonics of group number 1, okay? So for group number 1, this is group 1. For group 1, what we will do, Bicha? What group 1? Yes. Yes, Kadri, Mrunal, Suhas, Sai. Yes, Supriya. Okay. Now, for group number 1, little Nathan knew rubies cost fortune. Okay. So, this is in English. Little Nathan knew rubies cost fortune. in English. And if you talk about, ma'am, in Hindi, what is that? Leena ki Ruby se friendship. Okay, Leena ki Ruby se friendship. Then group number 2, this is group number 2, this is group number 2. If you see this here, this is group number 2. Okay. Okay. If you see the group number 2 here, that is Be My Cat Strong Brother Rocky, right? Be My Cat Strong Brother Rocky. Be My Cat Strong Brother Rocky. Or you can also remember it like this. You can also remember it like this. Beta mange car scooter baap razi. Beta mange car scooter baap razi. In Hindi, like totally your choice which you want to learn, right? Then group number 30, okay, group number 30, that is boron family. This is in P block, right? For boron family, what you have to remember? For boron family, it is baal gaye Indian tel se, right? Baal gaye Indian tel se, that is in Hindi. In English, it is bag it. B-A-G, bag it. Okay? Group number 16, 14, that is carbon family. It is Kasi gaye Sant Prabhu. What is it? Kasi gaye Sant Prabhu. Next, what you can also remember? Can simple Germans sing perfectly? Can simple Germans sing perfectly? Okay, that is in English, right? Then we have group number 15. Group number 15, that is no pity after some bad memories, right? No pity after some bad memories. Someone give you bad memories, right? Then you will have no pity on them. No pity after some bad memories. No pity after some bad memories. Till here you don't need to remember. Till here you should remember, okay? So you can also learn it in Hindi like na pee aisi sharab bhai. Na pee aisi sharab bhai, okay? Like this also you can remember. Group number, I would really advise all of you to remember things. If you're not able to catch it in English, remember this in your regional language, okay? That mother tongue is like, we all remember our mother tongue like on tips, right? So I would advise you, in your own mother tongue, you can make your own mnemonic related to your life. That will be more beneficial for you, right? Okay. So here it is. Next one is Usse tepo. Usse tepo. That is, old scientists seek the precious light. This you don't have to remember. Till here you should remember. Old scientists seek the precious light. Old scientists, oxygen, sulfur, selenium, beryllium, polonium. Right? Then last one is, this is group number 17. That is father called brother in a taxi. Right? Father, ma'am, full lag. Guys, I have no idea why there is so much lag. Okay. Okay. Ma'am, for me, no lag, ma'am. Even I have no idea why you're saying lag. Now, okay? Okay. Now, group number 17 is fluorine, chlorine, bromine, iodine. I would advise you don't need to have any mnemonic for this. It's already very simple, right? But yes, those who want to have mnemonic, father called brother in, right? Father called brother in. This you don't have to remember, okay? These are not in usually used. So till here, if you remember, that will be better for you, right? Then there is group number 18. That is the noble gases. Here it is. He never arrived. Karine X-rayed raccoons. Okay. So he never arrived. Helium, neon, then argon, krypton, xenon, radon. Okay. So that is your group number 18. That is noble gas. Okay. Now, this you won't be able to remember this like in like maybe 1 day or 2 days. This you have to like paste some mnemonic, right, as a chart on the front of your wall so that you see this daily, and that's how you will be easily able to remember it. Like how I remember this is लीना की रूबी से फ्रेंडशिप, बेटा मांगे कार स्कूटर बाप राजी, बाल गए इंडियन तेल, काशी गए संत प्रभु, नापी ऐसी शराब भाई उससे टेपो, फ्लोरीन क्लोरीन ब्रोमीन आयोडीन, हीना हीना नीना और कैटरीना, जेनॉन रेडॉन, right? That is how I remember this, right? So Shoti Choi, your choice how you want to remember this. Now I would want all of you to make a mnemonic on this and let me know in the comment section the mnemonic in your regional language. In your regional language, right? Which is your mother tongue. In your mother tongue, make the mnemonics of all the groups here, right? So that you can remember this, so that you can also help someone else, right? Okay, that would be really, really good for you. Now, next is 3D series. Next is 3D series. So this is 3D series. Where the 3D series is, here you will see the 3D series. Here, beta, you will see the 3D series, right? Okay. This is the 3D series. Here, what you will see. This is what should be on your tips. Saktiv kar man fi ko ni ku jan. If you can remember this, that would be great. Saktiv kar man fi ko ni ko jan. Okay. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Okay. That is must very important for you, right? And those of you who have no idea, ma'am, how to remember this, then this English mnemonic is for you. Scary tigers vanish, clever mice and cheese near cages. Clever mice find cheese near cages. Okay. Scary tiger vanishes. That's actually the opposite of real, right? Scary tiger vanish. Clever mice find cheese near cages. Okay. So, saktiv kar man fi ko ni ku jan. Okay. So, jan, it is not written here, right? Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Okay. Till here you have this. Okay. Understood? Now, once this is totally your task, right? Now you have to, what you have to do, what's your task? In next 10 days, I am giving you 10 days to remember this. 10 days I am giving you, because it's not possible that, okay, I am here and you are listening to me and other day you will be able to learn everything. It's not possible. It's not practical, right? I am giving you 10 days. After 10 days, I want you to comment over here that yes, ma'am, I have learned everything, right? Okay. Yes, ma'am, that the group number 1 to 13 to 18, 3D series. These are some of the very, very important sequences that should be on your tips, right? From block chemistry, D and F block, periodic P block, then coordination chemistry, chemical bonding, right? All of these things are based on the periodic classification, okay? Understood? Yes. Now, even now it is lagging here. Even now it is lagging here. Let me check the internet quality here. Excellent connection, they are saying. I don't know why it is lagging then. Right? Excellent connection, it is saying. Okay. Now, even now it is lagging. What? Yes, ma'am, lagging a bit. Ibu is saying, ma'am, lagging a bit. Okay. Nani Sarita is saying lagging. Even now it is lagging, or what? Even now. I don't know why it is happening. I don't know why it is happening. Because they are also saying it's excellent connection you have. Let me see if there is some problem with the OBS. OBS is also fine. Beta OBS is also fine. Okay. Mm, wait a minute. Let me see if I can reload. Yeah, I reloaded it. Chalo. Okay. Now let us see what next. What next in inorganic chemistry. So first is what should be on your tip. So I'm writing group number 1, 2, then group number 3 to 18, then 3D series. Okay. These should be on your tips. These should be on your tips. Only then it is possible to learn inorganic chemistry on your tips. Okay. Next thing is the general. Now I'm talking about general ionization, size, and electronegativity. Generally, you should know that what exactly are these things. Okay. So I'm going to tell you that one by one. So first is the size. Okay. First is the size. If you talk about the size here, right? In size, what you should remember that one thing is along the period, right? Second is down the group. This is along the period, This is down the group. Okay. So now few things I'm going to tell you about here, right? So along the period is what? Arey yaar, I don't know why it is happening, yaar. Should I end the class or what? I don't know why this is happening. I have the stable internet connection, excellent connection it is showing. Even then, why it is like, even then, why it is happening so? Okay, now I'll ask the final time. Okay, is there any lag or not? Is there any lag or not? Only after that I'll teach. Ibu is saying yes, ma'am. Fesa is saying no, ma'am. Akash is saying no, ma'am. Nitya is saying no, ma'am. What else? Who else? Akash, no lag, ma'am. Those who are feeling the lag, then they are now. If there is lag in between, also you'd let me know. Full lag, then I think there might be some problem on your side because right now at my point there is no lagging, right? Okay. If you all are saying no, ma'am, so I'll take it as no only, right? Okay. So now first thing is size along the period and down the group. Okay. So along the period, what is it? Along the period, one thing you should remember here, I'm not going into anything like cramming or that stuff, right? Let's talk about basics here. What is happening along the period? See, if you talk about the atomic number, right? This is 1, this is 2, this is 3, 4, then 5, 6, 7, 8, 9, 10. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. That means along the period, atomic number is increasing by 1 and 1. Okay? Atomic number is increasing here. In atomic number, what happens? Right? For that, you should have the knowledge of atom. Okay? For that, you should have the knowledge of structure of atom. So I'll firstly teach you the structure of atom. General structure here. I'm not going to get into full structure of atom. Generally, I'm telling you what exactly is an atom. Right? So here you have a nucleus which is very small, which is very dense. Right? Dense means it is very heavy. Inside the nucleus, you have neutrons and protons. Outside you have electrons. Outside you have electrons that are revolving in a circular orbit. This is by Bohr, right? But according to quantum numbers, quantum theory, you can find the probability of the electrons. So let's say you have n is equals to 1. in n is equals to 1, we know that I'll not get into like fully into this quantum numbers, right? If you want to learn fully the quantum numbers, then also let me know in the chat box, because this is neutron and proton. Whenever I am imagining a structure of atom, I'll imagine like this only. Though in reality, it is the probability of finding the electrons. But whenever I'm imagining the atom, I'll imagine it like this. Why? To actually understand how the size is decreasing or increasing, right? So let's say in along the period, what is happening? One atomic number is increasing. That means we are adding one electron, and whenever atomic number is increased by one electron, one neutron, one proton is also increased. So that means whenever we are increasing the atomic number here, whenever I say that atomic number is increasing here, what is happening? What is happening? This is one. It is one electron. I'm not going to talk about protons here. Sorry, I'm not going to talk about neutrons here, because my focus is directly upon the Z effective. Z effective is the effective nuclear charge. Okay, you will see this term, right, throughout the chemistry, right? Z effective, effective nuclear charge. See, if you talk about the atomic number, right, that is the number of protons, that is atomic number. Okay, Z effective is, we know that this positive is nucleus and the outermost electron are negative charge. Nucleus is positive. That means there will be some interaction, attraction between all of them. There is something positive, something negative. There can be interaction between both of them, right? So here, what can happen is the neutrons, the protons and electrons will be attracted towards each other, right? Now see one thing. Proton cannot get out of its nucleus by simple means. It cannot get out of the nucleus. It's not possible for proton. But electrons are revolving around it, right? So right now I am not going into s orbital, p orbital, d orbital. That I am not focusing on, right? Right now we are just talking about the shells. That is principal quantum number. I am only talking about the shells, or I am only talking about the orbits. Here it is n is equals to 1. Here it is 1. Here it is 2. Okay. So if you see this here n is 1, here n is 2, right? N is 1 means here this is positive, this whole is positive, 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 right? Now what will happen here? This positive charge is going to attract the outermost, the electrons here. Let's say your atom is so small. If your atom is small, let's say in hydrogen, what you have in hydrogen, you have one nucleus and you have only one electron. So this outermost electron is attracted by the positive nucleus here, right? And let's say you have two electrons here. Now what will happen? One positive charge is increased, one negative charge has increased. But can you see one thing? Can you see one thing? When you added second electron here, the distance has not increased. The distance of positive charge and nucleus has not increased. But this positive charge has increased and one electron has increased. That means if I talk, this positive charge will have a charge attraction here. This positive charge will have attraction here. So when the atomic number is increasing, because this overall positive charge is increasing to the individual electron, it will have more attraction, right? It will have more attraction. That is called Z effective, right? What is Z effective? Now guys, what is Z effective? Z effective is atomic number minus sigma. Sigma is the shielding effect. Sigma is the shielding effect. It is the shielding effect. What is shielding effect? Shielding is from the inner core electrons. Okay. What is the inner core electrons, ma'am? So if you say this electron and this electron, both will experience the positive attraction, right? That is called the nuclear charge. This Z is called the nuclear, this Z is called the nuclear charge. How much charge a positive nucleus is applying on the electron to attract the electron towards itself, that is called the nuclear charge. Okay. Now, shielding means protecting, right? So what is happening here? Let's say one more electron we have added here. One more electron we have added here. Now, these are the inner core electron. These are the inner core electron. Inner electron. So what will happen, right? This proton has to attract this electron, this electron, this electron as well. 3 electrons. But firstly, because the distance is less, it will attract the inner core electron. And inner core electron will act as a shield, right? Like you have bodyguards. In the same way, inner core electrons will act as a shield here for the outermost electron. Okay, so this is the outermost electron, inner core electron, that are, let's say you have this also is now inner core. Let's say you add one more electron in some orbit, let's say here, right? So all the electrons that are present in this orbit, in this orbit, in this orbit are acting as the shielding electron, right? They are shielding the outermost electron. Okay, so when we are talking about Z effective, right, we are saying that how much attraction we are giving to the outermost electron. Okay, how much attraction we are giving to the outermost electron, that is called Z effective. Is that clear to everybody? What is Z effective? Is that clear or not? Z effective is how much attraction proton, or you can say how much attraction nucleus is giving to the outermost electron, right? Keeping in mind that the inner core electrons are going to shield or protect or screen the outermost electron from the proton. This you can understand with the one very simple thing. Let's say this you can understand with the daily life example. Okay, so let's say you are this. Okay, let's take an example of Indian Army. Okay, the situation that we are in right now. We are in what kind of situation? We are in war situation right now, right? So this is who? This is our like favorite enemy, right? The one who is always mocking India, right? So this situation is Pakistan, right? And this is us, and this is us. This is us, right? So in between, who is shielding us? Tell me. In between, who is shielding us? This is Pakistan. This is electrons, outermost electron, right? This is us. And in between, there is our Indian army who is shielding us, who is protecting us, right? So that these missiles that are sent to destroy us, right? This army is neutralizing these missiles that are sent to destroy us, right? So this is shielding, protecting, screening by Indian army to the Indian civilians, the Indian citizens, right? By this, I think you can understand what is exactly screening effect, what is Z effective, what is screening effect, and what is positive and this negative charge here. Is that clear to everybody or not? Right? Is that clear to everybody or not? Students, is that clear? Is that clear? Okay. Yes. Now, one important term here, one more term to understand here is, one more important term to understand here is inert pair effect. Inert pair effect. Okay. Inert pair effect. What is inert pair effect? This you must have seen. See, when you will study inorganic by yourself, you will see this like every corner, you will see inert pair effect, right? Inert pair effect is the same thing, right? Inert pair effect is the same thing, like this is nucleus. These are the orbits where the electrons are, okay? Let's say outermost electron is present in this orbit, okay? Now you have to find the inert pair effect. Inert pair effect is very simple. It says that this is nucleus. Right now we know that this positive nucleus and this electron, it will attract it. So if orbit, let's say if too many electrons are in between, all these electrons are going to protect this outermost electron from this nucleus, right? All these electrons, all this electrons will be shielded or protected or screened by the inner core electrons, right? Now, screening effect also is different from different subshells. So S has maximum, then you have P, then you have D, then you have F. That is the screening effect. That is the power of screening effect. It's like we can say that it's not like everyone, every army is able to save the citizens, right? Only a very like the well-trained army, right? Like our Indian army can save, right? So this is our Indian army, right? This S is our Indian army who is saving the citizens, who is screening the citizens. This F is an army which is not well trained, right? Not well trained to save the citizens of their country, right? So here, this positive nucleus is attracting the outermost electron. But let's say if you have S orbitals in between, it will be able to have good screening, right? If you have P orbital, it will have less screening, D even less screening, F has the poorest shielding effect. F has the poorest shielding effect. Okay, understood? Now, if you see this here, now these are the screening effects. Then ma'am, what is the inert pair effect? Inert means inner electron. Because of this screening effect, what will happen? Let's say it does not, let's say like in D orbital, it has poor screening effect, right? It has poor shielding effect. Now tell me, if because we are protected right now, reason being because our army is very strong, right? The army is able to neutralize all the missiles to protect us. What if the army is not able to do that? Then what will happen? What if the army is not, then tell me what will happen. What if the army is not able to do that? Then what will happen? Then we all will be gone, right? So that means if it has a poor shielding effect, electron will be attracted towards the nucleus and the size is going to decrease. So when, because of the poor shielding effect of some orbitals, the size, the attraction increases and the size decreases, that is called inert pair effect. Okay, that is called inert pair effect. Is that clear to everybody? What is screening? What is shielding? What is Z effective? What is inert pair effect? These are the basic terms that we will use in inorganic chemistry. Okay. Now, next is, let's talk about the size here. Let's talk about the size. There are 4 factors that are important. First one is size. Okay. Size of atom along the period and down the group. Along the period. Now tell me, along the period, what I told you, what is happening? Along the period, what I told you, what is happening? Along the period, can I say one thing, that along the period, as you are moving along the period here, 1 electron, 1 proton you are adding, right? So here, if let's say you have 1 positive, you have 1 electron, right? Here you have positive, you have 2 electrons, right? Here you have positive, here you have 3 electrons. Can you see what exactly is happening? Can you see what exactly? The positive charge, here it is 1, here it is 2 positive charge, here it is 3 positive charge. Here it is 1 positive charge. 1 positive charge is attracting 1 electron only, right? It's like when there is, see, one simple thing I'll tell you. These are the borders, because I'll relate to whatever is happening right now. Okay, we'll talk about that situation only so that we can understand, right? Even the situation, even this concept more clearly. And we can also see what is happening right now, right? Okay, so this is positive proton, this is electron. We know that, like, this is one, like say there is some soldier over here. This electron is the soldier, right? This positive thing wants to destroy this soldier. So this is easily possible because this positive charge is 1, electron is 1, so attraction is possible. But in this case, what we have 2 positive charges. That means someone standing, right? This is me, this is next to me, someone is standing, right? And 1 electron is on this side, 1 electron is on this side. So To one electron, what is visible is 2 proton. To this electron, what is visible is 2 proton. But to one proton, to me, I can see only one electron. That means, can I say Z effective is increasing here. The attraction will increase here. Why attraction will increase? Because these 2 protons, let's say here you have 2 protons, here you have one electron here, one electron here. These 2 protons can easily attack this one electron, can easily attack this one electron, right? If it would have been the situation, if situation would have been 2 protons and 2 electrons that are next to each other, then the situation would be different. Right now, electrons are not at one position. Electrons are rotating. It's not like they're sitting next to each other. So to one electron, 2 protons can easily attract, 2 protons can easily attract. That means Z effective is definitely increasing here. Is that clear how Z effective is increasing? Is that clear, students, that Z effective is increasing? That means the attractions are increasing. If I say the attractions are increasing, the size is going to decrease, right? So in positive and negative is attracted to each other, the size is going to decrease here. So can I say here that size will decrease? Can I say here that size will decrease? Is that clear to everybody or not? Is that clear that the size is going to decrease? What is the reason behind that? Right? Okay, students? Right? Okay. Now, next is, second is along, down the group. Down the group things are different. Down the group things are different. If you see this, down the group things are different. Why? Because down the group, one electron is not added. It's like too many electrons are getting added down the group. So this is down the group. And here what is happening? This is 1, this is 3, this is 11, this is 19. It's like this. 1, 3, 11, 19, this is 37, this is 60, 54, I think. 55. 55, this is 89, 88, 87. 86 no 87. Okay, so can you see it's not like I am adding one electron here. Okay, so we know that if you talk about one group here, one group, this belongs to 1s, this belongs to 2s, last electron will be ns1, last electron will be ns2, here last electron will be np1, this will be np2, this will be np3, this will be np4, this will be np5, this will be np6. Okay, n will vary here. That means we are adding all together a new orbit. Right? So in that case, you will feel that, ma'am, again we are adding the electrons. But how we are adding the electrons? How we are adding the electrons? If electrons are getting added, the protons are also getting added, but the electrons are getting added in groups. Okay, in groups means, let's say 2 people are fighting, two groups are fighting with each other. Okay, so here if I say that here is so many protons and here you have one electron, then you're adding one more orbit here which has the same number of electrons in the outermost shell. So what is happening that you are adding electrons in group, right? You're adding electrons in throughout the orbit, you are adding the same amount of electrons, like these many electrons you are adding by magic number. So that is the reason, right? Z effective will not decrease, Z effective will not increase here, right? Because the distance is also one factor here. You are increasing the orbit number also. So from the nucleus, the distance of the orbit is also more. Because the distance of the orbit is more, that is the reason it's not possible. You can say that you're adding one more you are adding not one more, you are adding electrons here, but electrons you are adding that are at distance, right? So that is the reason Z effective will not increase here, right? That is the reason down the group, because new orbit altogether is getting added, the size will increase here, okay? The size will increase here because one orbit is getting added here, okay? Because one orbit is getting added here, right? Okay. Ali is saying there is lagging. Is there lagging, buffering? Arey yaar, I think today I wanted to teach few more things, but I think the internet doesn't want me to teach. I don't know why this is happening, even though internet is like of very good quality. Either this is due to what is happening in the country, because maybe some because where I am right now, their electricity is also not that great, right? So I don't know. The internet connection is good only. I don't know why this is happening. I don't know. No idea. I have no idea, guys. I know when I say lag, then students say no lag. I don't know. Still buffering, beta. That. Arey, arey, arey. No lag, lag, no lag, lag. Okay. Now, if you see down the group, because let's see, this is 1s1, this will be 2s1, this will be 3s1, this will be 4s1, this will be 5s1, right? So, you are adding new principal quantum number only, you are adding new shell, right? That is the reason down the group what will happen, size will increase, okay? Size will increase. Now, next is ionization enthalpy. Ionization enthalpy. Ionization enthalpy. Next is ionization enthalpy. So in ionization enthalpy, what you should remember here is, right? I don't know. I think I'm not that near Pakistan that it should affect here. I'll ask the other teachers if they are also facing the same or not. I'll ask other teachers also if they are also facing the same or not, right? Only then I'll be able to understand, right? Ma'am, your voice and audio is clear, no buffering. Akash is like, ma'am, it is clear. Okay. I think maybe to some students it is happening, right? Maybe to all of you it is happening, right? No idea on that, because some are saying yes, some are saying no. That I'll see after the class only. I'll have to see the video whether it was there or not. Right? Or maybe to some students it is buffering, to other students it is not, because in my, like here it is showing excellent connection only. So I have no idea, either this excellent connection is not able to understand whether the connection is good or not, right? Okay. So here if you see ionization enthalpy, students, let's talk about ionization enthalpy. Ionization enthalpy is to take out the electron, okay? So when you have atom, you have electrons, you need to take out the electron. The energy that is needed to take out the electron is called ionization enthalpy, right? Okay. So now, if you see this here, simple thing that you should know is that, see, if size and ionization enthalpy are inversely proportional to each other. Ma'am, what do you mean by that? See, simple thing is, if size is small, then the nucleus and the attraction of outermost electron is more. That's why the size is small. So it is very difficult to take out the electron. That means the ionization enthalpy will be very high. So if size is small, ionization enthalpy is very high, right? So if size is very large, okay, size is very large. This is nucleus, this is outermost electron. So attraction of nucleus and outermost electron is not that much. So you can easily take out the electron from the outermost orbit. That means we can say that ionization enthalpy is very less here, right? Ionization enthalpy is very less here. First thing is you should know about that thing, that ionization and the size is inversely proportional. Second point that you should know here is that if you have half filled and fully filled, electronic configurations are stable. Half filled and fully filled electronic configurations are stable. Let's say you have Ns2Np4. Let's say you have Ns2Np4. Then you take out one electron here. It will become Ns2Np3. Right? It will become Ns2Np3. Right? So that means you are converting it into a stable configuration. If I say that by doing this, you will be get converted to a stable configuration. That means it would want to lose the electron and get converted into a stable electronic configuration, so that that is the reason this can easily remove one electron here. So easily one electron will be removed here. Ionization enthalpy will be low. But if you talk about you have Ns2Np3, then taking out electron here is not possible. Why? Because this is half stable, half filled configuration, right? In P you have 6 electron. This is having 3 electron. It is a half filled configuration. So taking out electron from here is very easy. Very difficult. So it's not possible. IE is very high. In fact, it will be infinite. It's very difficult, right? Okay. Okay, students. Now next is third one is electron gain enthalpy. But I am not going to tell you, we are not discussing full P block or periodic table. So no exceptions, nothing I'm going to tell you here. I'm just telling you the important things that are required. Okay. So here, just the general terms I'm discussing here. So electron gain enthalpy, students, what is electron gain enthalpy? Listen to this. Electron gain enthalpy, and there is one more term that is called, anybody? There is one more term that is called electron affinity. Electron affinity. So a very simple example I'll take here, right? So electron gain enthalpy and electron affinity, what is the difference, right? Electron gain enthalpy, basically it's we are giving the electron to the, in ionization enthalpy we were taking the electron. In electron gain enthalpy we are giving the electron. Okay, in electron gain enthalpy we are giving the electron to the atom. Now here what you will see, that when I am okay. See this. So if you talk about this, we have done now. Here we are. Electron gain enthalpy. So if you talk about the electron gain enthalpy, this is when you give the electron, right? So when you give the electron, what will happen exactly, right? It's like you can compare it with when you eat the food, okay? So electron affinity is your tendency, that how much you want to eat, whether you want to eat food or you don't want to eat food. So if your electron affinity is positive, electron affinity may be positive, it can be negative, right? If electron affinity is positive, that means the tendency to gain electron is good. It wants to gain electron. Negative means it does not want to gain electron, right? So this is the ichha, the tendency to eat something. Let's say you want to eat something. So your electron affinity will define whether you want to eat it or you don't want to eat it, right? Then you have electron gain enthalpy. Electron gain enthalpy also can be positive or it can be negative, right? So if we are saying the electron gain enthalpy is positive, right, that means after eating something, let's say you really want to eat something, like your mama has prepared like some dosa, right, along with vada, you're like very excited to eat it. You're like, yes, I'm very positive, I want to eat it. So your electron affinity is positive. And after eating that thing, you'll be very happy. That means you will release energy. After gaining, you really release of energy happens. Release of energy, that means, which is a good part. If some reaction is releasing the energy, that's a good thing. That means that reaction wants to happen, right? Okay. Then, if you say that it does not want to gain any energy, let's say electron gain enthalpy is positive. That means when you forcefully, it does not have any tendency to gain the electron, but you forcefully make it gain the electron, then what will happen? After gaining, no release of energy. Or you can say it requires energy. You have to forcefully, it requires energy to gain electron. That means you have to forcefully, let's say your mama has prepared which thing, what is your, like, which dish you hate the most? What is the dish that you hate the most? Yes, students, what is the dish that you hate the most? Which dish? So let's say, I'll just write one thing here. For example, you are eating dosa. Okay, dosa will give you, this is electron gain enthalpy, this is electron affinity. This is dosa. Let me know in the chat box which is the dish that you hate the most. So when you eat dosa, you're very happy. So your electron gain enthalpy is positive, but after eating, you will release energy. You will be happy after eating. But let's say you are eating something that you hate. Okay, that you hate. So I genuinely hate khichdi. I hate khichdi. Okay, I don't like very healthy food. Anna? So I hate khichdi because it's like when you are ill, you have to eat khichdi. So that's why khichdi means illness to me, right? So let's say your mom has prepared khichdi for you. She'll feel very negative. You'll be like, I don't want to eat it. When she forcefully make you eat it, then you will not release any energy. You will require energy. That means she'll have to scold you to make it eat, right? So that is, if electron affinity is negative, electron gain enthalpy will be positive. That is the most confused part, where students don't realize that what is electron affinity and what is electron gain enthalpy and what is the difference between both of them. Spinach you hate, right? You replace it with spinach. Okay. Whatever you hate, you can replace. Broccoli you hate, you replace this with broccoli. Right? You hate whatever, right? You can just replace it here. Right? Okay. Right, students? Is that clear? Right? Electron gain enthalpy and electron affinity. The difference, is that clear or not? Is that clear or not? Fourth part is electron negativity. So whenever we talk about this statement, electron negativity, you will use throughout your chemistry part. You will use it throughout. Okay. What is electron negativity? You will use it throughout. Okay. So electron negativity is what? Electron negativity means, let's say you have a covalent bond, that is A and B, right? In a covalent bond, Those students who have no idea, ma'am, what is bonds, ma'am, you tell us about bonds. I'll just write it here simple, right? There are three bonds here, right? Three bonds here. First is ionic, then you have covalent, then you have coordinate, okay? Ionic is where you have transfer of electron, okay? Ionic is where you have transfer of electron, right? This is sharing of electron. Coordinate is also sharing of electron. I'll tell you what is the difference between all these things, okay? So here if you see, in very simple language, I'll tell you what exactly are these things, okay? So here, if you see this thing here, let's say you have Na, you have Cl, okay? Na and Cl, see, if you know the atomic, we will also talk about quantum numbers in the end, okay? So if let's say you have Na, so we have 1s2, 2s2, 2p, 6, 7, 8, 9, 10, 3s1, okay? This is 1s2, 2s2, 2p6, 3s2, 3p5, okay? This is the electronic configuration, right? If you want me to write down electronic configuration, how to write that, let me know in the chat box, okay? We'll do that as well. Now, if you see this thing here, right, what you will understand that it has to lose one electron, it has to gain one electron. Why? Because everything in this universe wants to be stable, right? And either zero, either full or half is stable, right? So that's why basically it wants to have octet rule. Octet rule is what? Octet rule is that it wants to have 8 electrons in the outermost shell, right? So here you have how many electrons? 8 only. See, if it loses 1 electron, then outermost shell will have 8 electrons, right? That is 2 plus 6 plus 2, 8. Here it has 5 plus 2, 7. So after gaining 1 electron, it will have full octet rule will be applied here. That means 1 electron will be transferred from this position to this position. So that is how you have Na positive, because it will lose the electron. This is Cl negative because it will gain the electron. So cation is formed when you lose 1 electron. Anion is formed, you can also write it here. Cation is formed when you lose electron. Cation is formed when you lose electron. Anion is formed when you gain the electron, okay? Anion is formed when you gain the electron, right? So that is why we have ionic compound, that is Na positive, Cl negative, right? Okay. Next is covalent. What is covalent? That is sharing of electron. So let's say you have hydrogen, which is 1s1, right? You have Cl, that is 1s2, 2s2, 2p6, 3s2, or you can also talk about different parts here, right? Let's not talk about any specific compound here, right? You can generally talk about one thing, okay? So for covalent bonds, I'll talk about one thing here, right? Okay. So in general only I'll tell you, because in detail we will discuss this in hybridization, okay? So here what you have to understand, sharing means, let's say this A and this is B. This A has 1 electron extra, this B has 1 electron extra. They decided that this will also not lose the electron, this will also not lose the electron. What they will do is, they will share this electron, and this will be your, wait a minute, let's say this is its electron. So they will share the electron here. That is called covalent bond. But in covalent bond, 1 electron is from A atom, 1 electron is from B atom. Okay, the shared pair, 2 electrons that are in that sigma bond are from different atoms here, right? That is for covalent bond. In coordinate bond also there is sharing of electron, but here what happens, this is A and this is B. So here what happens is, this has, let's say, one lone pair of electron. Okay, it has 2 electrons. Now, here what will happen? It will share these 2 electrons with this B. Now, in this bond, if you draw this bond A and B, in this bond, both the electron are of A. Both the electron are of A, or both the electron are of B. Why? Because it is sharing the electron just like covalent bond only, but here both the electron are from one atom, not for the other atom. Okay, that is called covalent bond. Is that clear? So in covalent bond, one atom is acting as a donor, other atom is acting as an acceptor atom. Okay, one is donating, other is accepting, also sharing. Right? Is that clear? What is covalent? What is coordinate bond? Yes, student, is that clear? Now, after this, let's talk about electronegativity. Electronegativity is very simple. If you have coordinate bond, let's say A and B, you have coordinate bond. This is giving you, let's say, this electron. This B is giving you this electron. Okay. In reality, the situation is not like this. In reality, the situation is this. This is A, this is B. Let's say A is more clever. Let's say A is more clever. The one who is more clever, right? That will have both the electrons. So let's say A is more clever. So A will have this electron and this electron towards itself. So that means it will be minus this sign and minus this sign, right? So here, what do you mean by this thing? This simply means that the one which is more electronegative will have the shared pair of electron that are shared in the covalent bond. Shared pair of electron will be towards itself, the one which is more electronegative. Okay, the one which is more electronegative will have the shared pair of electron towards itself. That is called electronegativity, right? And fluorine is the has the maximum electronegativity. With 4 is the electronegativity of fluorine. Don't worry, we'll discuss about this in detail in periodic classification. But this is for those students who are about to start class 12 and they're clueless about class 11th inorganic chemistry. If you have no idea about these things, you start with inorganic chemistry of class 12. Even then, you will be clueless only, right? Okay. Now, next part is, let's discuss about the quantum numbers. I'm not going to tell you the quantum numbers. Ma'am, are you going to tell us the formulas of quantum numbers? No, nothing like that I'm going to tell you, right? Simply, I'll tell you the basics of quantum number here, right, which are required in your class 12. One thing is, you should know what is N, what is L, what is M, what is S, right? Or you can also draw it as ML, this is MS, right? This is principal quantum number, this is azimuthal quantum number, magnetic and spin quantum number. Principal quantum number, if you discuss, that is 0, this is 1 to infinity. This is actually called shell. This is actually called shell. Okay, or this is also called as orbit. You can also call it as orbit. This is subshell. This is subshell. This is subshell, right? This is ML is orbital. This will tell you the orbital, which orbital it is present in. This will tell you the spin. Okay, this will tell you the spin. Now, if you see this here, this is from 1 to infinity. This is going to be from 1 to infinity. L is going to be from this is going to be from 0 to L. 0 to N. Right? N minus 1 it will be. Okay, 0 to N minus 1. ML, orbit number is minus L to plus L, right? And this is always either plus half or it is minus half. Now, I am going to take one example of N is equals to 4. Okay, I am going to take an example of N is equals to 4. If let's say you have N is equals to 4, then what is going to happen? Is it useful for class 11th? Yes, it is also useful for class 11 because already if you know the basics, then it will be definitely you will have a higher thing when you are in the class learning the things, right? Okay, because learning the important topics is these basics are going to teach you the important topics. But one thing, if you are just stepped in class 11th, then this is not at all important. I would not advise you for that. Reason being, if you have just stepped in class 11, then it will be very difficult for you to grasp all these knowledge, all these important points, because I am just concluding class 11th. I am not discussing it thoroughly, right? So firstly, learn that chapter, then you can go through this particular lecture, right? So if you have n is equals to 4, just remember one thing, L will be from 0, 1, 2 and 3. For this, 0 means S, this means P, this means D, this means F. That is the most important point. 0 means S, 1 means P, D means 2 and F means 3, right? If you talk about S here, for S we know that this L is equals to 0. So ML will be equals to 0 only, right? ML will also be equals to 0, right? That means there will be only one, only one box here. That's why for S we only draw one box, right? For P it is, ML is from -1 to +1, right? That is why it is 1, 2, 3. So that is -1, 0, +1, right? For D it is, ML is equals to -1, -2, because it is 2 now, so it will be -2 to +2. So it will be -2, -1, 0, +1, +2. So it is going to have 5 boxes here. 1, 2, 3, 4, 5, right? Then you have F, right? That is -3, 2 + 3. That is going to be -3, -2, -1, 0, +1, +2, +3, right? So here it is going to be 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and this is 7, right? That is the reason we draw these many orbitals. So, now remember one thing. When I talk about S, when I simply talk about P, D, these are the subshells. These are not the orbitals. S is not an orbital. S is not an orbital. D is not an orbital. This is an orbital. If I define that this is for 4, so this will be 4s is the orbital, right? This is 4p, this is 4d, this is 4f. Now, these rooms here, these boxes are the orbitals. So, 4p has 3 orbitals, 4s has 1 orbital, 4d has 5 orbitals, 4f has 4d has 5 orbitals, 4f has 7 orbitals. And in each orbital, you can have, you will always have, this is the combination of Hund's, Pauli's exclusion, because Pauli exclusion principle says that you can't have third electron here, right? And Hund says that you always have to fill the electrons in the opposite spin should be there. So here it is 1, this is 2. These should be opposite to each other, right? So this is in accordance with Hund's principle and Pauli exclusion principle. See, Hund state that, I'll tell you this when we have these, let's say I'm filling the electrons here. This is D, okay, 1, 2, 3, 4, 5, okay. Now let's say Hund states that these all are degenerate. See, all the orbitals belonging to one subshell, if let's say we are talking about these are belonging to, these 5 orbitals are belonging to 4d, so all have same energy, okay. So remember degeneracy. What do you mean by degeneracy? Degeneracy means degeneracy. This also you will see in class 12 so many times, this will be repeated. Degeneracy means same energy, right? So all the orbitals belonging to one subshell will have the same energy, right? So Hund states that whenever you are filling the orbitals, you will not fill it like this. This is 1, this is, let's say I want to fill 5 electrons. So you can't fill it like 1, 2, 3, 4, 5. This is a wrong way of filling the electrons. How you are going to fill the electrons? Firstly, all the degenerate orbitals should be filled, singly filled. 1, 2, 3, 4, 5. Let's say now I want to fill one more electron, then I'll fill it here. Now I want to fill one more electron, now I'll fill it here. So that is the right way of filling the electrode. Firstly, all the orbitals belonging to degenerate orbitals, it will be singly filled. Only after that they will be paired up. Okay, only after that they will be paired up. Right, students? Now, that is about degeneracy, right? Next is this we have done. Next is, students, the energy. Okay, then you should know the energy. Pauli exclusion, I told you that Pauli exclusion says that in one orbital you should have only 2 electrons which are oppositely spin, right? Now, one thing you should know here is energy. Energy, just remember one thing. I'll give you simple trick here. That will be, this is S, this is P, this is D, this is F. This is 1, 2, 3, this is 4. So how you will draw it? First you write S 2 times, then write PS 2 times, PS, PS. Then write DPS 2 times, DPS. Then again DPS. Then write FDPS 2 times, FDPS, FDPS. Right? So what we have written here is, we have written different things. 2 times S, 2 times PS, 2 times DPS, 2 times FDPS. Okay, this is how you're going to write it. Then start S with 1, 1, 2, 3, 4, 5, 6, 7, 8. Right? Then start with P, that is starting with 2, 2, 3, 4, 5, 6, and 7. Then starting with D, that is 3, then it is 4, then it is 5, then it is 6, and that's it. F is starting from 4, so F will start from 4, 4, then 5, and that's it. Okay, this is the increasing order of energy. This is the increasing order of energy. Increasing order of energy. So whenever you are going to fill the electrons in the electronic configuration, you will always fill the lower energy level first, then move to the higher energy level. Okay, then move to the higher energy level. Till here, tell me, is that clear or not? Okay, till here, guys, tell me if that is clear or not. Till here, is everything clear or not to you? Everybody? Everybody? Now, next is, okay, we have talked about the energies here. We have talked about degeneracy here. Then let's talk about, ma'am, let's say, ma'am, I want to now, let's talk about scandium. Scandium is 21. Okay, that you will know from periodic table. Scandium is 21, that you should know from 3D series. Saktiv, Karman, Fico, Nico, Jan, that you should know from 3D series. So scandium is 21. How are you going to fill the electrons here? This is very useful for your class 12. Full class 12 is based on the electron full inorganic coordination chemistry and DNF block. If you don't know the electronic configuration, how to fill the electronic configuration of 3D series, you won't be able to solve the questions of DNF block and coordination chemistry, right? So 21, how you will fill this? Always remember, you will firstly fill the nearest noble gas, that is argon, that is having 18. Then you will have 4s, then you will have 3D. Okay, because till here you have, till 4s what you have, this is argon. Okay, till here you have argon. 1s2, 2s2, 2p6, 3s2, 3p6, that is total 18. Till here you have argon, then 4s, 3d, 4p. So in scandium to zinc, you just need 4s and 3d. So 4s is 2, 3d is 1. Okay, so that is how you're going to fill it. Now, if you talk about the electronic configuration of 3D series, I'll just directly write here. This is Saktiv, Karman, Fico, Niku, Jan. Okay, so how you're going to write it? If you say this is 21, 22, this is 23, 24, 25, 26, 27, 28, 29, and this is 30, right? Now what we are going to do here? Simply, we know that argon will be there, right? We know that argon will be there. So how we are going to write the electronic configurations here, right? So this will be 4s, this is 3d. So write down 4s, 3d, 4s, 3d, 4s, 3d, right? 4s, 3d, 4s, 3d, 4s, 3d, 4s, 3d, 4s, 3d, and last is 4s, 3. Now, if you see this here, this is 21, it is 21, 22, 22, 23, 23, 24, 24, 25, 25, 26, 26, 27, 27, 28, 28, 29, 29, and zinc will be, because in s orbital 3 are not possible, so it will be 2 and 10. Okay. Now, this chromium here and this copper here is the exception. It's not this, it's not this, it is 4s, 3d, 4s, 3d. But as I told you that half-filled configurations are more stable here, right? So what will happen? One electron from 4s will jump to 3d. It will be 1 and 3d 5 and 3d 5. It will be 1 and 3d 10. Because half filled and fully filled are more stable. So that is the exception of chromium and copper that you must know. Okay, this is very useful. This you have learned in structure of atom in class 11th, but this is directly useful in DNF block and coordination chemistry, right? In like almost magnetic movement, colored complexes, D transitions, or you talk about simple questions related to the let's say ionization enthalpy or even electrode potential. All these are related to the electronic configurations of 3D elements. Okay, got it? Yes, everybody? Is that clear? Now, next is this we have done. Now let's talk about hybridization. Okay, let's talk about hybridization. Hybridization. For hybridization, what you should remember, right? I know you have seen the difficult parts of hybridization. So I'll tell you one simple thing. First is, what is hybridization? Let's draw a molecule of CH4. So this will also help you to understand what was hybridization. So firstly we will draw carbon. In hybridization, you will apply all the concepts that you have learned till now, right? So for carbon, what you have? Carbon is 1s2, it is atomic number 6, it is 1s2, 2s2, 2p2. That is the electronic configuration. Hydrogen is 1s1, right? So if you draw it here, this is carbon, this is carbon, this is having 1s2, 2s2, 2p2, right? So that means in 2p you have 2. So can I just draw 2p here? This is 2s, this is 2p, right? 2p and this is 1s, right? 2s2 and 2p. Why, ma'am, you have not drawn 1s here? Because only for just one thing from chemical bonding. Now I'm going to tell you some important things from chemical bonding, okay? So from chemical bonding, you should know that only the outermost orbital will take part in the bonding. Okay, only these things that I am drawing right now are directly useful in organic chemistry. You will not use these. Yes, you will use hybridization part in VBT theory in coordination chemistry, and in organic chemistry also you will use this, right? So here it is. 1s2 you will not write here because only the outermost electron will take part in the bonding. So it is 1, 2, 2p is 2. So only singly filled first you will do because all are degenerate. Here it is 1s1. So can you see this here? If I write 1s by this thing, right, that would be great, right? Now students, see one thing. This is the ground state. If you talk about the excited state, here you have only 2 unpaired electrons. Now I'm telling you the conditions of bonding. Okay, I'm writing the conditions of bonding here, right? What is the condition of bonding? What is the condition of bonding? First is only outermost electron, outermost orbital take part. Second is it will take part in the excited state, not in the ground state. So this is the ground state. This is the ground state. You need to have the excited state. So what will happen in the excited state? Electrons will jump. Okay, electrons will jump. This you have studied from Bohr theory. See, Bohr theory is individualistic theory. Directly you won't apply. You will not apply that in class 12th, but the applications, the concept behind it, you will apply. So according to Bohr theory, we know that when we excite the electron, that shift in the next orbit. Okay, this is what is happening, right? So it will shift here. So what will happen? 1, 2, 3, 4. Now, see one thing. Only those electrons can take part. Only those orbit will take part which are half filled. Only those electrons in an orbit which are half filled will take part in the bonding, right? This in the ground state, these two electrons cannot take part in the bonding. But in excited state, they can take part in the bonding. So this is excited state. Now, if you see this here, ma'am, this is excited state. Now, next is what you have to remember. Next part that you have to remember here is, yes, ma'am, this is excited state. This is carbon, right? Excited state. Now, I'm not teaching you hybridization now. I'm firstly telling you why hybridization was adapted here, right? So, if I say that one orbit is S, right? Other is, this is Px, this is Py, this is Pz. Achha, I forgot to tell you about S and P and Y, no? Wait a minute, before we are to tell that, I forgot to tell you the shapes here, okay? That also you should know, right? See, S orbital has which shape? Then you have P orbital has which shape, right? See, S orbital, it has only one box that is having this shape, right? That is spherical shape. So you can draw it here. That is spherical shape, right? Then P orbital has dumbbell shape. P orbital has dumbbell shape. But in this case, what will happen? Because this is how we draw it. One is Px, one is Py, other is third is Pz. So what you will have here is, you will have 1, 2 and 3. What you will see, this is Px, this is Py, this is Pz. So this will be along x-axis, this is along y-axis, this is along z-axis. So that is Px, Py and Pz, right? Now if you talk about d orbital, d subshell, we know that it will have this kind of, how many orbitals it has? Students, how many orbitals in d subshell? It has 5 orbitals. So that means 5 orbitals means 1, 2, 5, 10 electrons can be there, right? Now, here how many orbitals you have? dxy, dyz, dzx, dx square minus y square, dz square. Okay, so here what we have? 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. That means if I draw between the axis, one is along the axis. Now here what you will see, this between the axes, if it is between x and y, this is dxy. If this is between y and z, this is dyz. If this is between z and x, this is dzx. If this is x and y, but it is along x and y, this is dx square minus y square. This is dz square, where this is z, right? But there is also one electron cloud here. These are the shapes. Okay? These are the shapes. Yes. Okay. Yes, yes. So that was the shape. After that, we were here, right? So s orbital is this one. Now I have one is px. So I can draw it like this. One is py. You can draw it like this. One is pz. Right? You can draw it like this. Okay. So what will happen here? You have one orbit of 1s because there is 4 hydrogens here. That means 4 1s you have. Right? So you can draw it 1. This is 2. This is 3. This is 4. Are you able to understand that or not? Right? If I draw this, let's say I'm drawing it. Okay? Let's say I'm drawing it. This is carbon. Carbon has how many? It has 1s, right? 1 2p, other 2p, and the third 2p also. Third 2p where to draw? This 2p you can draw it like this. This 2p you can draw it like this. This 2p you can draw it like this. This 1s you can draw it like this. Okay, these are the 4 orbitals that it has, right? Now if you see this here, this is 1s, so this is bonding with 1s, this is forming one bond with 1s, this is forming one bond, this is forming one bond, right? Then this is half filled, right? Let's say electrons are like this, and here in this case, in 1s, it will be like this. In 1s of hydrogen, the electrons will be opposite like this, okay? Because if you want to have bonding, if you want to have atomic bonding, then electron should have opposite spin. Opposite spin. Okay, they should have opposite spin. Now, can you see one thing here? If I say electrons are this, here electrons are overlapping, here electrons are overlapping, here electrons are overlapping. Can't you see, ma'am? What, ma'am? If this is the case, then that means 3 carbon hydrogen bond where carbon is having P and hydrogen is having S. 1 carbon hydrogen bond where carbon is having S, hydrogen is also having S. Right? That means 3 bonds, 3 CH bonds should have same bond length and 1 CH bond should have different bond length. Right? But that is actually not the case. In real, but all CH are same. In real, all CH bond length are same. And that will give you the concept of hybridization, that is mixing of the orbitals. So in hybridization, what will happen? So students, in hybridization, what will happen? What you will see that in hybridization, mixing of orbital, after this step, mixing of orbital will happen. You will have 4 sets will mix to give 4 different. See, if you have 4 energy orbitals that are mixing, they will give 4 energy orbitals only, but that will be the hybridized energy orbital. Okay, that is going to be the hybridized energy orbital. So what will happen here? This will form 1 sp, because 1 s and 3 p are involved. sp3, 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 sp3. So you'll have 4 sp3 hybridized orbitals, which will have 4 electrons here that will overlap with 4 s orbitals of hydrogen. That means what will happen here? This is carbon. Carbon is going to have 4 hybridized orbitals, and always hybridized orbitals are this small circle, this big circle. This is the hybridized orbital, okay? 1, then this is 2, this is 3, and this is 4, okay? And this one is 4, right? These are the 4 hybridized orbitals, and hybridized orbitals have same energy. They have same energy, okay? So here you will have 1s, 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 1s of hydrogen, where 2 electrons of half-filled and opposite spins are overlapped, right? Okay. Here you will think that, ma'am, then it should be like this. Ma'am, then this should be like this, right? Ma'am, it should have a shape like this. This is carbon, 1 hydrogen, 1 hydrogen, 1 hydrogen, 1 hydrogen. But in reality, this is not the shape. The structure is CH, H, H, H. And this if you see this in 3D, then you will realize what I'm telling you, because in 2D it looks different, in 3D it is entirely different, okay? So this is in 3D what you have, okay? This is in 3D what you have, right? So here, all the angles are 109 degrees, right? This is in 3D. It may in 2D it looks like this, in 3D it looks like this. So all the CH bond lengths are same here, right? So that is called the tetrahedral geometry. That is how with one shape you can have different geometries of different hybridizations, right? So directly I'll switch to the next thing that is important. Hybridization, this happens, this happens. Now next thing is, ma'am, in the exam hall, do I have to make these structure and then I'll realize, ma'am, what is the shape? Ma'am, who will tell me, like, firstly, how I will identify the hybridization? Ma'am, do I have to do all these things, then I'll land to the hybridization? No, right? Directly, how you will judge the hybridization? So this is the compound here, right? So here directly what you will do in your exam, so this is sigma plus lone pair. Sigma plus lone pair only you have to calculate, okay? Sigma, and that too with the central metal atom. How many sigma, not pi bond, only sigma bonds. And this is the hybridization according to that, okay? This will be the hybridization. Or I would like to make one more thing here, that is not only hybridization, right? Let's make the structure also. What will be the structure then, okay? Because this is what you have learned in chemical bonding. I am sure that those students who were in class 11th, they might have totally not in contact with the chemical bonding, then there is chance that you will forget, right? So let's see this. This is sigma plus lone pair. This is hybridization. This is hybridization. And this thing here is called geometry. In geometry, I'm not going to tell you lone pair, this and that I'll cover in detail. I'll cover that in chemical bonding. Well, when we will start chemical bonding, I'll cover that, okay? Here we are just discussing what is useful for you in your class 12, right? That means the topics that are directly related. Otherwise, from chemical bonding only, they will ask you so many questions, right? Okay, that we will do in detail, right? See, if your sigma plus lone pair is 2, then hybridization is sp. If it is 3, then hybridization is, it is 2, 3, 4, 5, 6. It is possible. So I'll just draw it 2, 3, 4, 5, and 6, right? So here, if sigma plus lone pair is 2, it is sp. It is 3, it is sp2. It is 4, it is sp3. It is 5, it is sp3d. It is 6, it is sp3d2. Okay. And here, if you see this here, I will just give you the simple thing here. See, if you're talking about the, wait a minute, the session. Okay. See, if you're talking about simple sp hybridization, that is going to be like this. AB, that is going to have linear geometry. Okay. Simple, that is AB. So you can answer it. That is going to have simple linear geometry. Talking about sp2, that is going to have trigonal planar geometry like this. Okay. As you can see, the angle between each of them is 120 degree. 360 divided by 3 is 120, no? So it will have a trigonal planar geometry that is going to have 120 degree angle, right? Then tetrahedral is this geometry. Tetrahedral is this geometry. Now, as you can see, even if I put it like this, 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 all are same only. So they all have same angle, right? This geometry is called tetrahedral and the angle is called 109 degree 28 minutes, right? Next we have is 5 that is having trigonal bipyramidal. So why trigonal? This is trigonal. If you see this here, this is trigonal, right? That I showed you. Now, if you have one angle over it, this is forming a pyramid. One bond below it, that is also forming a pyramid, right? So two pyramids you can form here. So that is why it is called trigonal bipyramidal. Bipyramidal. Okay. Now in this case, what is the angle? See, when you talk about the geometries that are, see, if you can see here, it is 120 degree. If you can see here, it is 120 degree. 120 degree angle is there. Angle 90 degree is also there. So this bond and this bond is forming 90 degree angle, right? But this bond and this bond is forming 180 degree angle as well. So three angles you have: 120, 120, 120, 90 and 180. Last is octahedral, that is for 6. This is called octahedral. Now why this is called octahedral? Because see, 8 phases you will have. One phase, second phase, third phase, 8 trigonal phases. First trigonal phase, second trigonal phase, third trigonal phase, fourth. Then similarly, 5th, 6th, 7th and 8th. 8 trigonal phases you have. That is why it is called octahedral. Octahedral. And here you have 90 degree and 180 degree, right? So this bond with this bond is forming 90 degree angle. This bond with this bond is forming 180 degree angle. Okay, so two bonds we have here, 90 and 180 degree. Okay, students, right? That was the base of inorganic chemistry for all of you. I have covered like the basic things, right, that you must know before starting inorganic chemistry of class 12, right? Okay, if you're not planning to do in detail chemical bonding, periodic classification, P block, right? If you're not planning to do that in detail, then at least this much you should do so that you're able to understand, so that you don't waste class 12th of inorganic chemistry as well, right? But let me know in the comment section if you also want me to take up full detailed lectures of class 11 organic, inorganic and physical chemistry. Let me know in the chat box, let me know in the comments as well. Well, waiting for your comments. And students, for students who are like want to get enrolled into an offline institute, and here I was saying the scholarship, if you also want to have scholarship here, then students, in the description box you will see IVSAT program here. IVSAT is the scholarship test, right? If you get good marks in the scholarship test, you can avail up to 90% scholarship, right? And what are the institutes, ma'am, where we have our offline centers? So you can see this over here, that our offline centers are there in Tamil Nadu, Andhra Pradesh, Telangana, Punjab, Maharashtra, Delhi, Bihar, Odisha, Rajasthan, Pondicherry, Karnataka and Uttar Pradesh. Okay, so these are the centers, offline centers that we have. So you can go through the offline centers list here and you can check that out, right? Everything is in the description, right? Everything is in the description for you. And those students who are preparing for different exams for their JEE, right? After JEE, they are preparing for different exams. So this is the list of test series for you, right? So you can go and check that out. What like which exam you are preparing for, you can check out the test series here. And for advanced students, we have these two things for you. That is the rank accelerator book, which will help you revise all the questions. Like you can even see the twisted, most important question, and not only 2025, 2026 students as well. You know, at this point, you have enough time to practice for JEE Advanced questions, right? So I would advise you, if you're even preparing for JEE 2026, purchase this book, because in 1 year at least you will be able to do all the questions from these books, right? So you can click on here, and here you will get the link, and here you will get the like these books, that is at 1299, because see, JEE Advanced is just very near. That is the reason at this point this is at sale, right? once JEE Advanced is over, again the sale will over, right? So that's why I'm saying that for 2026 also purchase this book, right? Because that will be useful even you are purchasing it from like in sale, right? 38% off it is, right? So that will be beneficial for you. Okay, students, then bye-bye, take care. Yes, let me know in the comment section what are the other lectures you want me to take up. Yes, Pritika, you can let me know in the comment section. Okay, then bye-bye, take care. Bye-bye.